The Sun is a high-temperature plasma sphere, and if we could cut it open, we would find it divided into multiple layers. But since we can't directly observe its interior, how do we know about the Sun's internal structure? Although we can't see inside, we can make predictions using certain methods. For example, through helioseismology, scientists observe vibrations on the Sun's surface and use the frequency and speed of these oscillations to infer the density, temperature, and pressure of different regions inside the Sun. Additionally, scientists study neutrinos, which can travel directly through the Sun and reach Earth. By detecting these neutrinos, researchers can analyze and deduce information about the temperature and density of the Sun's core. So, what is the internal structure of the Sun? The Sun's interior is generally divided into 6 layers. First is the core, which is like a massive nuclear reactor with extremely high temperatures and pressures. This causes hydrogen atoms inside to continuously undergo nuclear fusion, releasing enormous amounts of energy. The temperature here exceeds 15 million degrees Celsius. Above the core is the radiative zone. In this region, the energy produced in the core propagates outward in the form of radiation. However, due to the high density, photons constantly collide with other particles as they radiate outward. As a result, it may take at least 100,000 years for photons to travel from here to the outer layers. Next is the convective zone. In this region, plasma undergoes intense convection, and the temperature generally drops to below 2 million degrees Celsius. Beyond the convective zone lies the photosphere, which is the visible surface of the Sun as seen from Earth, with a temperature of about 5,500 degrees Celsius. Here, the plasma is in a state of boiling motion, continuously rising from the Sun's interior and then cooling and sinking. Above the photosphere is the chromosphere, a thin layer about 2,000 kilometers thick. This layer is filled with hot gas jets, which are the material ejected during solar flares. Finally, there is the corona, the outermost layer of the Sun, with temperatures as high as 2 million degrees Celsius. Corona is only visible during a solar eclipse or through special X-ray images. Why the corona is so hot remains a mystery, and there is no definitive answer yet.